Hi there. For this video, we'll be discussing about the point-slope form of a line. So recall that in the introduction video on equation of lines, we know that we can also obtain the equation of a line by simply knowing its slope as well as one of its points. Sorry for that. Recall that this is given by y minus y sub 1 equals the slope m times the quantity x minus x sub 1. And this out here is called the point slope form of a line. Now we'll be trying to derive how we arrived at this form. So we'll have this illustration as well as some mini proof about it. So take note that our goal is this one. So to show this, first we let xy be a point. More specifically, we let xy be a point on the given line. So say this one is xy, and this xy, since we just let it to be a point, then we know that xy is arbitrary, which means that x and y can take any values. Moreover, we choose xy such that this is not equal to x sub 1 comma y sub 1. The reason being is that we'll be using this point to get the slope of the line. If xy is equal to our given point, then by applying the slope formula, we'll not be able to obtain the slope, since by slope formula that will simply be y minus y sub 1 minus x sub 1, but when they are the same, this becomes 0 over 0, so we can't really obtain anything. Now from here, we use the slope formula. So recall that the slope is given by m equals the change in y over the change in x, which is also equal to, given 2 points, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Since we are already given the x sub 1 and the y sub 1, what we do is we set our chosen points to be x sub 2 and y sub 2. Then, by the formula, we'll have here m to be equal to y minus y sub 1 over there, x minus x sub. From here, note that we can multiply both sides by x minus x sub 1, because we know that x and x sub 1 will never be the same or equal. So we know that x minus x sub 1 is not equal to 0. Therefore, we'll obtain... let's try to move some stuff out here. There. Therefore, we'll obtain y minus y sub 1 equals m times x minus x sub 1. Note that since here y and x are arbitrary, then it acts out as our variables in this case. And so what can we observe? As we can observe, we have already arrived to our goal formula. Therefore, we have finished deriving the point-slope form of a line. Now, you may write this one out here in your notes, as this will be important to remember in our examples later on. So here's our first example. Given the slope m equals 5 and point 23, we find the equation of line in first the point-slope form, then the slope-intercept form, and lastly the standard form. Now feel free to pause this video so you may try this example on your own. Okay, let's start. So first, for the point-slope form, recall that the point-slope form is given by y minus y sub 1 equals m times x minus x sub 1. So this is the formula that we got above. And now, since we already have the slope m and we have a point, so we can set this point to be x sub 1 and y sub 1, then we just plug in these values on our formula. So we'll obtain out here, let's put this one, we'll obtain y minus 3 equals 5 times x minus 2. And this one out here is our point-slope form. Next, how do we obtain the slope-intercept form from this one? Take note that the slope-intercept form is of the form y equals mx plus b. Let's move this so we can focus on this form. So how do we obtain this one now that we don't have the y-intercept of the line? Well, what we can do is we can manipulate these values out here. So we can first distribute the 5 out here. So that will give us y minus 3 equals 5x minus 10. Afterwards, we can move negative 3 to the right to obtain y equals 5x minus 7. And as you can see, this is already parallel to our form. To be even more exact, we can write this as 5x plus negative 7. And so we had arrived already at the slope-intercept form. So as you can see from the point-slope form, we are able to obtain the slope-intercept form. So now we know 3 points in the line. Since we now already know the y-intercept, which is -7. So we know that 0, -7 is also a point on the line. Lastly, we convert this to the standard form. We can use the slope-intercept form. Oops. This one. We can use this one to get the standard form. So recall that the standard form, let's move this down here. Recall that the standard form is given by capital AX plus capital BY equals capital C, wherein A, B, and C are constants and X and Y are variables. Also, A, B, and C must be integers with A being positive. So given that, using y equals 5x minus 7, we can start by moving x to the left side, 5x rather. So that will give us negative 5x plus y equals -7. Again, the coefficient of x must be positive. Therefore, we multiply -1 both sides to obtain 5x minus y equals 7. And this out here is our answer. So as you can see, given just the slope and a point, we can find the equation of line in 3 forms. Let's have the second and final example. So for this, we are tasked to convert 4x plus y equals -16 to point slope form and identify its slope and one of its points. So feel free to pause this video to try this out for yourself. Okay, now note that there are various ways on how to solve this one, but I'll be using the point slope form and a simple observation to answer this. So my solution will probably be one of the basic ways, or the most basic way on how to solve this. So first, note that the point slope form is of the form y minus y sub 1 equals m times x minus x sub 1. So we'll try to convert the given into this form. So we have here 4x plus y equals -16. So first, as we can observe, all the x, the x variable must be on the right side, while the y variable must be on the left side. Given that, we know that we should move 4x to the right. So this will give us y equals -4x minus 16. Now there are various ways on how we can solve this, but one way is to observe that we can factor out -4 in these. So that will give us y equals -4 times x plus 4. Now we're almost close to our desired form. what else do we need to do? Observe that we can write y as y minus 0, and on the left side, note that we can write x plus 4 as x minus negative 4. And as you can see, this is now parallel to our given form. So we have converted the given equation to a point-slope form. Next thing to do is identify its slope. Clearly, the slope m is given by negative 4. So we have here m equals 4. After that, we can identify one of its points. By the point-slope form, we know that the ordered pair x sub 1 and y sub 1 is a point of the line. So in this case, negative 4, comma 0 must be a point in the line. That is, we write here negative 4 and 0. So this is a point in the line. And actually, take note that negative 4, 0 is the x-intercept of the line. So using the point-slope form, we actually obtain not only its slope and not only one of its points, we also obtain its x-intercept. So that is the power of using or knowing various forms of a line. Before I end this, here's an exercise that you can work on. So, we have if a line with slope 3 contains the point 1, 10, find the y-intercept. So, it might seem crazy at first because we're dealing with points and slopes, but we need to find y-intercept. But there are various ways on how you can solve this one. Whatever that method is, the first thing to do is to apply the point-slope form to obtain an equation. After obtaining that equation, you can either convert that equation to the slope-intercept form, like we did in the first example, or you may set x to be 0 to obtain the y-intercept. So that is all up to you. And that's it. I hope you enjoyed this one. Feel free to comment down below any suggestions and recommendations that you have for this channel. Also, if you have an answer and solution to this exercise, you may share it down below and I'll be happy to verify if that answer is correct or not. So that's it. I hope you enjoyed this one, and that is all for this video.